In this video, we will solve a problem on profit maximization. This question was asked by a brother Zakir Khan on YouTube. The question is, given profit function is pi is equal to 1 upon 3 q cube minus 3q square plus 5q plus 3, where q denotes the output and pi denotes the profit. We have to find out the profit maximizing level of output and maximum profit. Okay, so what we are being given, we are being given the profit function, and let's write it again here. So we have 1 upon 3 q cube minus 3q square plus 5q plus 3. This is our profit function. Okay, now the first order condition for profit maximization requires, okay, the condition is that the marginal profit should be equal to 0. Okay, so first order condition for profit maximization requires our marginal profit should be equal to 0. And what is marginal profit? Marginal profit is simply the derivative of profit function with respect to output. Okay, so the derivative of profit function with respect to output denotes our marginal profit. Okay, if we take the derivative of this function with respect to q, so we have 1 upon 3 derivative of q will be 3q square. By power function rule, I have explained it n number of times how do we do the differentiation. Minus, we have 3, the derivative of q square will be 2q. Okay, plus derivative of q will be 1, so we are left with 5 here, and derivative of a constant is 0, and we set it equal to 0. Simple thing. First order condition for profit maximization requires that the marginal profit should be equal to 0. Okay, so this 3 and 3 gets cancelled. We are left with q square minus 6q plus 5. It should be equal to 0. Okay, or let's write it in this fashion. D pi upon dq should be equal to this. It should be equal to 0. Now we have a quadratic function here. We need to factor out this by factorization. We should get this, since this is in the standard quadratic form. Okay, we should get the sum of two numbers in such a fashion that their addition should be equal to -6, and the product of the same two numbers should be equal to the constant term. Okay, so if we write here -5 -1, so -5 plus -1 is -6, -5 into -1, minus into minus will be plus here. Okay, so we will get +5. Okay, sum of the two numbers should be equal to -6, and product of the same two numbers should be equal to 5. So we can split it out as, that is, we have q square. In place of -6q, we will write -5q and minus q. So -5q minus q again, sums up to -6q. In place of +5, okay, in place of +5, I can write -5. Okay, it is basic mathematics here, nothing unusual here. Now let's factor out it. We have, if I take q common, I will be left with q minus 5, and if I take here -1 common, I will be left with in the last two terms, if I take -1 common, so I will be left with q minus 5 again, and we set it equal to 0. This implies we get, let's take q minus 5 again common. Q minus 5, if I take common, I will be left with q minus 1, and we set it equal to 0. It means either our q minus 5 is equal to 0, which gives us q is equal to 5, or q minus 1 is equal to 0, which implies q is equal to +1. Okay, so we got two values for profit maximization. Rather, we got two values which satisfy the first order condition. We need to find out which of these two output levels in fact maximize our profit is. For that we need to take this second order condition. Okay, second order condition. Now what is second order condition for profit maximization? Simple thing that tells us the derivative, the second derivative of profit function, that means d square pi, or let's write it here simple d. I am writing here delta. We don't need to write the delta because we have only one variable in the profit function. So we have d square pi upon dq square. It should be less than 0 when evaluating at critical points, that is when q is equal to 5 and q is equal to 1. Okay, at q star. Now first let me explain this stuff with the help of example, graph. That will make more sense here. Okay, if I draw the graph. Okay, so we got two values for output, q is equal to 5, q is equal to 1. Okay, if I draw the profit function, it will look like this. The intercept will be 3 here, so it is something like this. We will get this kind of profit function. Now this first order condition is used to find the marginal profit. That means the first order condition, if I write quantity on this side, profit on this side. Okay, so first order condition is being satisfied at 2 points. You can see when q is equal to 5 and q is equal to 1. Let us say this is q is equal to 1, and let us say this is here q is equal to 5. Okay, now first order condition says that the marginal profit should be equal to 0. That means we have marginal profit equal to 0 at 2 points. Here when d pi upon dq is equal to 0, this is our first order condition. And here also it is being satisfied because we got two values for this function marginal profit. So here also d pi upon dq is being satisfied. Okay, since we got two values, but we need to find out the maximum profit. Okay, so we got first derivative will not tell us whether we are at maximum or at minimum. It will simply tell us the slope of the profit function is 0. Okay, so first order condition tells us when we equate the marginal profit with equal to 0, it will give us the slope. Okay, slope is here 0 because it is horizontal. Here it is also 0, but we need to check which of these two will be actually our profit maximizing condition. Okay, so this denotes our first order condition. Okay, d pi upon dq denotes our first order condition. Let me use another color. Parishani, you go first order condition, and here it also explains our first order condition. Second order condition is used to check whether we are at maximum or minimum. Okay, now when first order condition has been satisfied, now the second order condition, that is d square pi upon dq square, when the value of this second order derivative is less than 0, that means slope is then decreasing. Okay, here you can see the slope is negative. So this denotes our second order condition. First order condition only tells us the marginal profit is equal to 0. Second order condition ensures that we are at maximum, and also here it is 0. But if our second order derivative came out to be positive, that means d square pi upon dq square, if it came out to be greater than 0, then we are at minimum. Okay, so these two conditions are for maximum and these two conditions are for minimum. Okay, but we need to find out the maximum. That's why I was trying to show you that second order condition requires that the second derivative of profit function with respect to output should be less than 0 when evaluating at the critical points. Okay, now let us say which of these two actually satisfy the second order condition. Okay, for that we need to find out the second order derivative. So this is our first order derivative. Okay, now let us write it here, that is d square pi upon dq square. Okay, I am just trying to see what is our second order derivative. This is our first order derivative. Okay, so derivative of q square is 2q, derivative of q is 1, so we are left with minus 6. Okay, derivative of constant is 0 obviously. So this is our second order derivative, and we evaluate it at the critical points. We have two critical points, q is equal to 5 and q is equal to 1. Okay, let us evaluate it at first at q is equal to 5. Now d square pi upon dq square, when q is equal to 5, let us see what happens. So we have 2 in place of q, we have 5, we have then minus 6, so this is 2 5s are 10, dahan eşittir 4, so we will get here 4, which is greater than 0. Okay, but as I have told you, second order derivative when evaluated at critical points, it should be less than 0 for maximum. Okay, but we are getting it as greater than 0, so this condition is for minimum. Okay, so this cannot be our profit maximizing output. When so our profit maximizing output cannot be 5, because when we evaluate this at okay in the second order derivative of profit function, it came out to be positive, but our answer should be negative. For that, let us check another and I am short of space here. Now d square pi upon dq square when evaluated at q is equal to 1. Okay, so when we evaluated at q is equal to 5, we got the second order derivative greater than 0, so that cannot be our profit maximizing condition. Now we need to evaluate it at q is equal to 1. Okay, checking this very condition, so this is not our profit maximizing level of output. So this is our second derivative, so we have 2 in place of q, we have 1 this time, so let's write it here, 1 minus 6. Here you can see 2 ones are 2 minus 6, which comes out to be minus 4, which is less than 0. That means second order condition is being satisfied when output is 1, because we got the second order derivative as negative. Okay, when output level is 1, that means our profit maximizing output will be, so our profit maximizing output will be equal to 1. Now we need to find out the maximum profit also. For maximum profit, simple thing, just plug the value of q is equal to 1 into profit function. So we have 1 upon 3, in place of q cube we have 1 cube, minus 3 into q square is 1 square, plus 5 into 1 plus 3. Okay, so we have 1 upon 3 minus 3 plus 5 plus 3, 3 cancel, 5 plus 1 upon 3 is 0.33, so we will get 5.33 and so on. Okay, so this will be our maximum profit, 5.33. Okay, let me repeat it here. First order condition just tells us the slope is equal to 0, and slope can be 0 either at maximum or minimum. Okay, second order condition is used to check whether we are at maximum or minimum. If the value of second order derivative came out to be negative, then obviously we are at maximum. If the value of second order derivative came out to be positive, that means it is minimum. Okay, I hope I make myself clear in this video. Thank you.